Hello guys, welcome back to my channel. Please remember to like and subscribe. Now today we'll be looking at an application of a basic trig identity. So we'll be solving the equation 2 cos squared theta minus sine theta equal 1. And what is important here is the interval where theta is greater than or equal to 0 but less than or equal to 2 pi. So I know the answers I get should actually be inside of this range. Now, when I see 2 cos squared theta minus sine theta, automatically comes to mind that this seems to be somewhat of a quadratic. The problem here is that the terms I have are different. So we have a sine theta, but we have a cos squared theta. But that is not a problem because we know the trig identities. So we can go ahead and say, recall that cos squared theta is equal to 1 minus sine squared theta. And you can go back and watch my video that I did on deriving these identities and how we apply them. So what it means is that where I have a cos squared theta, I can put a 1 minus sine squared theta there. So let us see what happens. So this is going to become 2, open bracket, we have 1 minus sine squared theta, close, minus sine theta. And we know once it's a quadratic, we're going to have to factorize so we can bring over the 1 at the same time. And this is equal to 0. If I expand this bracket, we have 2 minus 2 sine squared theta minus sine theta minus 1 equals 0. Now, normally when we have a quadratic, the highest power of a variable comes first. So we're going to have negative 2 sine squared theta first minus sine theta. Then, of course, 2 minus 1 is a positive 1 equals 0. At this point, there are two things we can do. We could replace the sine theta with a variable, which would make this equation easier to solve, but we can treat sine theta as a variable and solve the equation as is. So let me just rewrite it up here. So you have negative 2 sine squared theta minus sine theta plus 1 equals 0. Now we're going to be using the AC method, so we have negative 2 times 1, that is negative 2. The two terms we have are, when we multiply them, we get negative 2. But when we add them, we get negative 1, which is the coefficient of the middle term, which is sine theta here. So we could use negative 2 and we could use positive 1. So this is going to become negative 2 sine squared theta minus 2 sine theta plus sine theta plus 1 equals 0. We have four terms, so we can pair them and factorize. So these two, those two. So I'm going to have negative 2 sine theta. When I factor that out, I'm going to have sine theta plus 1. And over here, between sine theta and 1, we can only factor out a 1. So we still have sine theta plus 1 equals 0. So this gives me negative 2 sine theta plus 1 multiplied by sine theta plus 1 equals 0. And the concept is that if we have two terms or two things that multiply to give us 0, then one of them must be 0. What you're going to end up with now is negative 2 sine theta plus 1 equals 0, or sine theta plus 1 equals 0, which implies that sine theta is either going to be a half or sine theta is equal to negative 1. And we did have a video on with trig graphs to show you how when a graph is equal to 0, negative 1, or 1, we can simply use it to solve this equation. So let me do the sine theta equal negative 1 first. I'm simply just going to sketch a graph between 0 and 2 pi. Now, of course, you should remember what the graph looks like. Alright, we go up by pi over 2, so I'm going to have pi over 2, pi, 3 pi over 2, and 2 pi. The maximum value, recall, is 1, and the minimum value is negative 1. Now, in a scenario like this, we easily recall the graph by starting it at 0 here. So we go up where we have pi over 2 mapping up with 1. We come down to pi. We go down, that's down to negative 1, and we come back up. So if you follow this process, it's easy to sketch a graph like this. So when sine theta is equal to negative 1 between 0 and 2 pi, what it means is that theta would be equal to 3 pi over 2. Alright? Let us look at the second scenario. Sine theta is equal to a half. Now, bear in mind that for this scenario, we could go to our quadrants here. And to recall this, we said that all science teachers are crazy. So sine is positive in the first quadrant and in the second quadrant. Now, let me give this angle, the acute angle that we're going to get when sine theta equal to a half. Let us call it alpha. So alpha would be equal to sine inverse of a half. When I sine inverse a half, I'm going to get alpha to be pi over 6. Now, this is going to be in the first quadrant, it's pi over 6. It's also going to be in the sine quadrant as pi over 6. Now, bear in mind that the angles are measured away from the horizontal, the positive x-axis. So from here to here, that would be pi over 6. But when we go all the way around to here, bear in mind that right here we have pi. So we're going to have pi minus pi over 6, which is the acute angle there in the quadrant. So 1 pi, we simply just subtract the coefficients. 1 minus 1 6 would give me 5 pi over 6. So my second angle would be 5 pi over 6. So to conclude, we can simply put all three answers together here, and we can say therefore theta is equal, and if we want to put them in ascending order, we can go pi over 6, 5 pi over 6, and 3 pi over 2. These will be my answers for this question.